what is this video all about? Let's have a preview. Do watch the video till end to get all the insights.
Hey, how are you doing? Welcome to the next video of Java tutorial series. If you have missed the previous videos, check the link in description. In this video, we will be discussing mostly about concepts of objects in Java. So I will be explaining you the theoretical part first, followed by its example or the practical part. So let's begin. Our first topic for today is access modifiers. Technically speaking, access modifiers are used to specify the access levels for classes, variables, methods, and constructors. In simple words, it is used to restrict the scope of them on who can access them. They are also known as visibility modifier or Java access specifiers. There are 4 access modifiers available in Java: default access modifier, private access modifier, public access modifier, and protected access modifier. Let's see how each of them works. Default access modifier. It is set by default when no access modifier is specified. In other words, no one can access it from outside the package. What a package means is a group that encapsulates similar type of or related classes. In simple terms, it is a folder. When we create a Java project, we create packages, that is a path to a folder. Example, com.java.tutorial is a package. Here com, Java, tutorial, all these are folders. But it's created like inside com we have Java and inside Java folder we have tutorial folder. So if you create a class within a package and don't specify any access modifier, you won't be able to access it outside the package. Next is private access modifier. The methods or data members that are declared as private are only accessible within the class in which they are declared. In other words, no one can access it outside the class. Here's a note. Class or interface cannot be declared as private in Java since it will never be used if we declare it as private. Okay. So the next one is a public access modifier. It allows anyone to access the members of the class from anywhere. Classes, methods, or data members which are declared as public are accessible anywhere throughout the program. There is no restriction on the scope of public data members. Protected access modifier. It limits its access within the class and from the class that inherits it. So the methods or data members declared as protected are accessible within the same package or derived classes in a different package. So protected members can be accessed only in the child or derived classes. So now let's see an example to understand it better. So inside user credentials, we have 2 variables, username and password, but no access modifier is mentioned here. So we can see the nature of default access modifier here. If we comment out the username variable of user detail, it will not be able to access username from user detail. Because of default access modifier, it is not able to access it from user credentials as well. Let's do a sysout for password and extend class user credentials. Now the error is still there. It means with default variables cannot be accessed even from a class that it inherits, because default doesn't allow to access outside its package as class user detail and user credentials are present in different packages. Now let's change the access modifier for username and password as private and public and check it again. Now as you can see, it is able to access password as it is set to public but not username as it is set to private. It means public can be accessed outside the class as well, but private cannot be accessed outside the class. If we change private to protected and check again, now user detail is able to access both username and password. It means protected allows user detail to access from extended class user credentials. So protected allows access only within the class or within the inherited class. Now if we run this, only username is printed as only username is set in initializer block, not password. And we are calling the empty constructor, so value of password is not set. If we set password in initializer block, then it will also be printed in console. So now I hope the concept of access modifiers is clear to you. So coming to our next topic, that is classes and objects. In Java, everything is associated with classes and objects. Classes and objects in Java are two concepts which go hand in hand. You can't learn one without having the knowledge of another. Together they form the building blocks of Java. So what is a class? A class is a group of objects that contains common properties. So it can contain fields, methods, constructors, blocks, interface, etc. Now, classes can also be classified into two categories, that is built-in classes and user-defined classes. So built-in classes are the one that comes bundled within predefined packages in Java, which are developed by Sun Microsystems and are provided as a part of JDK. So basically, built-in classes are the predefined classes that comes along with JDK. So like some of them are string, system, exception, object, date, thread, etc. All these classes are built-in classes. Now second is user-defined or custom classes. So a user-defined class is the one that is created by the user. Now, are there any rules to create a class? If yes, what are they? So yes, there are some rules. That is, a class keyword is followed by the class name. A class name must start with a capital letter. A class name should not contain any spaces or special characters except $symbol and underscore. And the last one, that a class can only have public or default access specifier. Now let's see an example to understand it better. As you can see, this is a user-defined class which contains an access modifier, a class keyword followed by its class name. Now as discussed, class name can have underscore and dollar, but it should be same as the file name. That is what the error says. If we change it to private, it gives error because the class can only be public, abstract or final. Now, there are some predefined classes as well. Let's take an example of date class. Create an object and sysout. It will print current day's date. Okay. So this predefined class is present in java.util package and it represents a specific instant in time with millisecond precision. So in the similar way, there are many other predefined classes available. Like if you want to print any custom date, then we can create an object of a predefined class simple date format. We can create the object and provide the format and use it to parse our date. Now it will ask you to enclose it within try catch as it might throw some exception. So you don't need to worry about all this for now. Exception is a separate topic that will be discussed later. So let's now just print both the dates and see the output. Both the dates are printed correctly. So I hope with the help of this example, you're able to understand predefined and user-defined classes. Now let's talk about objects. An object in Java is an entity which contains its properties and behavior. In other words, it is a logical as well as a physical entity. So object consists of the following. It contains state, behavior and identity. So state is the data represented by the attributes and properties of an object. Behavior is the functionality that is defined by the methods of an object. And identity is a unique ID or a unique name that is identified by the JVM, which helps or which enables the communication between two or more objects. For instance, let's take an example of a car. So the color, type, average, manufacturer, all these are the state of this car object, and driving is the behavior. Okay. So there are three main steps to create an object, create a Java object, that is declaration, instantiation and initialization. Declaration is where you need to declare a variable with the class name as the data type. Okay. Instantiation is where you need to use the new keyword to create the object, and initialization is where you need to initialize the object by calling the class constructor. Also, there are three ways to create an object in Java, that is using a new keyword, using a new instance method and using a clone method. So now let's see examples to understand all these three steps to create an object and the three ways to create an object. So in our example, we have already created two objects. Let's see the three steps of object creation for our object. So here declaration is user credentials UC part. Then instantiation is use of new keyword followed by equals to, and initialization is user credentials brackets, or user credentials brackets, within the brackets we have passed John and Green, so that is initialization. So in this way all these three steps are written within a single line to create an object. Now let's see the three ways to create an object. First is using the new keyword, which we have already discussed. User credentials UC equal to new user credentials. Now second is using the clone method. So cloning is basically making a copy. So let's clone the UC object that we have already created. So to do that, write user credentials UC2 equal to UC.clone. Here we need to typecast our object to user credentials. Now let's print something using these objects to check if it works correctly or not. It is throwing clone not supported exception as we have not implemented clonable class. So let's do that and run it again. Now we have got output from both the objects. Now let's try the last method, that is use of new instance method. User credentials UC3 is equal to class.forName com.user.usercredentials dot new instance method. So we have to typecast it to user credentials. Here we have provided the class name with the package, with the entire package path to the class.forName method, else it will give us an error like class not found exception or something. So we have to provide the name along with the package name. Now let's print username with the third object as well, and we have got the output for all the three objects. So if you have noticed, object creation is performed only twice for the first and the last object. That's why initializer block and constructor are executed only twice. Second method, that is clone method, doesn't create a new object but just clones the existing one. Okay, so in this way object creation and object cloning is done in Java. So now I hope that this concept is clear to you. Moving to our next topic, programming methodologies. We have two commonly used programming languages, that is procedural and object oriented. So let's have a look on how they differ from each other. Then we will discuss about object oriented programming in detail. So in procedural programming, the program is divided into small parts known as functions, while in object oriented, program is divided into small parts known as objects. Procedural programming follows the top-down approach, that is breaking a bigger problem into smaller modules, while object-oriented follows bottom-up approach, that is fixing the smaller problems first and then integrating them to form a bigger module. There is no access specifier in programming, in procedural programming, so data hiding is not possible there, while it is possible in object oriented, as we have access specifiers like private, public, protected, etc. Then adding any new data or any function is easy in procedural, while it is easy in object oriented. Then as already said, that in procedural there is no data hiding is possible, so it is less secure, and object oriented is more secure. Then in procedural, overloading is not possible. That is the reason why adding new data or function is not easy in procedural, while it is possible in object oriented, so it is easy to add new data and methods. So some of the examples of procedural programming are C, Fortran, Pascal, Basic, etc. While examples of object oriented is C++, Java, Python, C#, etc. Okay. Now let's see object oriented programming in detail. Object oriented programming refers to an object-based programming model that focuses on declaring classes, creating objects from them, and interacting between these objects. What are the benefits of using object-oriented language? Advantages are productivity and maintainability is improved. Then there is faster development. There is low cost of development, and we get a higher quality software. Now let's dig into the 4 pillars of OOPS, that is object oriented programming. So the first one is encapsulation. Encapsulation is a mechanism where you bind your data and methods together as a single unit. It also means to hide your data in order to make it safe from any modification. We can achieve it by declaring the variables of a class as private. So implementation details are also hidden from the end user. Take an example of a capsule where the drug is always safe inside the capsule. Similarly, through encapsulation, the methods and variables of a class are well hidden and safe. Let's take an example to understand. So as you can see, this class user credentials is encapsulating all the variables and methods within it. By using the access modifiers, we can keep data safe within the class so that no one can perform any modification. If we make password as private under user detail, it won't be accessible. It will throw some error there. That is how encapsulation works. Like a laptop, when it is manufactured, they put components like hard disk, display screen, external ports, CPU, motherboard, etc. But at last, all these components are encapsulated together and the end product delivered to a user is a laptop. Now the second one is abstraction. Abstraction basically deals with hiding the details and showing only the essential information to the end user. It helps to reduce programming complexity and effort. You can achieve abstraction in two ways, that is abstract class and interface. So we will be discussing these topics in detail later, but let me just give you an introduction of what it is. So if a class is declared abstract, it cannot be instantiated, which means you cannot create an object of an abstract class. As discussed previously in this session, an interface in Java is a reference type or a model that a class can implement. In other words, it is a collection of abstract methods and static constants. Now let's see an example so that you will understand it better. We will see how interface and abstract class help us achieve abstraction. So here we have already created an interface user which has a method print user detail, but within interface we do not provide any implementation details. It is provided in the method that implements it, in our case user detail class, and for implementing we use the implements keyword. Now remember, extends is followed by implements, but vice versa doesn't work. That is, you cannot use implements first and then extend later. You have to use extends first and then implements later. It means if you are extending a class and implementing an interface together, then first inherit, then implement. For example, class A extends B, implements C. Okay. Now let's create an abstract class user personal info by writing abstract keyword before the class. Now let's add a method set email. Now in abstract class all the methods are abstract, that is it doesn't have any body. So if we add body within method, we will have to remove the abstract keyword from the class as well. Else we can add an abstract method and let another class extend it. And override its set email method. Now let's run it, and as you can see the email ID is printed on the console. So this is how interface and abstract method works. It hides its implementation details using abstract method and thus help us achieve abstraction. So these two topics will be discussed in coming sessions in detail later. So I hope for now that you have understood how abstraction works. Coming to the third pillar of OOPS, that is inheritance. Inheritance is a concept where the properties of one class can be inherited by another class. It helps reuse the code and establish a relationship between the classes. Now in Java, a class can be a parent class or a child class. So a parent class is the one whose properties are inherited by another class. It is also known as a super or a base class. Then a child class is the one which inherits the properties from another class, that is from the parent class. It is known as the subclass or the derived class. And this concept of inheriting properties from one class to another is what inheritance is all about. Its main advantage is code reusability. Now, inheritance is also of four types. The first one is single inheritance. In single inheritance, a class inherits the properties of another class. That is, it enables a derived class to inherit the properties and behavior from a single parent class. That is a one-to-one relationship. Okay. So if class A is your parent class and class B is your child class, then class B inherits the properties and behavior of class A. Okay. Second is multi-level inheritance. So in multi-level inheritance, a class is derived from another class, which in return is also derived from another class. That is, a class having more than one parent class but at different levels. So as the name suggests, multi-level, so at different level we have a different class and one inherits the another and the another inherits the third one. So if we have three classes like class A, class B, class C, so class B inherits the properties and behavior of class A and class C inherits the properties of class B. Here A is the parent class for B and class B is the parent class for C. So basically C inherits the properties and methods of class A along with class B. Okay. Then third one is hierarchical inheritance. So in hierarchical inheritance, a class has more than one child classes or subclasses. In other words, more than one child classes can have the same parent class. So if we have three classes like class A, class B, class C, so class A is the parent class and class B and class C are its child classes. Okay. The last one is hybrid inheritance. So hybrid inheritance is a combination of multiple inheritance and multi-level inheritance. Now it means that there will be multiple parent and multiple child classes. So if we have classes, if we have 5 classes, suppose A, B, C, D, E, okay. Here class A is the parent class of class B and class C. Then class B is the parent class of class D and class C is the parent class of class E. So here A, B and C are the parent classes and B, C, D, E are the child classes. Okay. Now let's see examples to understand all these types of inheritance. So for inheritance purpose, okay, we use the extends keyword. So here if you see, we have already implemented multi-level inheritance. Class user detail extends class user credentials and class user credentials extend class user personal info. It seems a little complicated, so to understand in a simple manner, let's create a separate package and separate classes, that is A, B, C, D, E, along with a sysout statement in each of them with its class name. For single inheritance, let's extend class A from B and run class A's print method using object of B class to see the output. Now for multi-level inheritance, let's also extend class B from class C and run class A's print method using the object of class C to see the output. So here B inherit from A and C inherit from B. So the data flows from A to B and B to C. That's why class name A is printed from C class as well. For hierarchical inheritance, let's extend class A from C as well. Now A is a parent class of B and C and print the same output. For hybrid inheritance, let's extend class D from C. Class A is inherited by B and C and class D is inherited by class C. I hope now it's clear how inheritance and all works. Inheritance topic is incomplete if we don't discuss about the diamond problem. There is something called as multiple inheritance where one can have multiple parent classes but just one child class. This concept is not supported in Java because it leads to ambiguity. So this type of inheritance can only be achieved in Java through the use of interfaces. Now, how it leads to ambiguity is Class D inherits the properties of class B and class C, and class B and C inherits the properties of class A. Now, due to this, class D will receive properties of class A from B and C both. Here's where the ambiguity occurs, as which version of A should D use, the one provided by B or C. Or let's assume we have a method print in class A and class B and C overrides the print method in their own way. Because D is extending both B and C, so if D wants to use the same print method, which method would be called? The one overridden by B or the one overridden by C? So in this way it creates ambiguity. Though it has a solution of virtual inheritance which is acceptable in C++, but it is not applicable in Java. In Java, one can use multiple inheritance using interfaces only, not using classes. Now the last and fourth pillar of object-oriented programming is polymorphism. Polymorphism means existing in many forms, where poly means many and morph means forms. Okay, so to achieve polymorphism, you have to satisfy these three conditions. First, an object can exist in many forms. That is, an object should exist in multiple forms. Second, all forms should reside within a single unit. Third, which form gets executed depends on the input. I will be explaining you all these three conditions, how it works. Okay. So polymorphism is also classified in two types, that is runtime polymorphism and compile time polymorphism. Runtime polymorphism refers to a process in which a call to an overridden method is made at runtime rather than at compile time. Method overriding is an example of runtime polymorphism, where method overriding is redefining a method of superclass in subclass. Okay. Second is compile time polymorphism, which refers to a process in which a call to an overloaded method is made at compile time rather than at runtime. Method overloading is an example of compile time polymorphism, where method overloading is when multiple methods with same name but different signature exist within a class. A different signature means a different number of parameters or different parameter data type or different sequence of parameters. Now let's see an example to understand it better. First, let's see method overriding. So let's override the print method of A in B and sys out something. Now if we call print method using object of B class, it will print whatever is given in the print method of A class, but if we override that method in B class that we have done, it will print whatever is present in the print method of B class. So now as we have overridden, it will print whatever is mentioned in the print method of B class, but if B class doesn't have any print method, then it would have printed whatever was given in the print method of A class. Next is method overloading. Now for that, let's create multiple calc methods with different types of parameters, different number of parameters and different order of parameters. Then we will print it to see how a single method can be used for different operations. But we cannot use the same name if argument type, argument number and order of arguments is same. Okay. So in short, we have created multiple forms of calc method which resides within a single unit, that is class C, and which form of calc method will get executed depends on the input, that is whatever value we provide, whether it is int or float. and how many number of inputs we provide, on that it depends which method will be executed. So now I hope concept of polymorphism is clear to you. Now I have covered the concept of objects and the 4 pillars of object-oriented programming. Now the last topic that we have for this session is runtime linking. In previous lectures we have discussed about JVM, right? So JVM is the one that is responsible for runtime linking. The Java Virtual Machine dynamically loads, links, initializes classes and interfaces. Okay, where loading is the process of finding the binary representation of a class or interface and creating a class or interface from that binary representation. Linking is the process of taking a class or interface and combining it into the runtime state of the JVM so that it can be executed. And initialization of a class or interface consists of executing the class or interface initialization method. Okay, so when you compile a Java program, a separate class file is generated for each class or interface in your program, right? So although the individual class files may appear to be independent, but actually they are connected to each other and have connections to the class files of Java API. So at runtime, JVM loads programs, classes and interfaces and hooks them together. So all this process is referred as dynamic linking or runtime linking. During runtime, JVM perform all these operations of loading, linking and initialization together to combine and to hook all the classes and interfaces together. So this is known as dynamic linking. So yeah, that's it for this video. You can find the interview questions in the end of this video. I have already discussed its answers in the video. If not, check the previous video to find out the answers, and you can find the link to get the code of all the examples shown in the video in its description. Write me down in the comment section if you have any questions or queries regarding the topics we have discussed. I will get back to you. If you want to stay updated with the next videos, do subscribe and hit the bell icon. Thank you so much. Have a great day.